Hello, and welcome to our Arista NetBuilders technical deep dive on DAN's monitoring fabric. We appreciate you taking the time to join us. My name is Tom Sammons, and I'm joined today by Mark Katter-Heinrich, David Candler, and Kevin Peterson, all systems engineers here at Arista. And in our 9th installment of our DMF NetBuilders series, today we're going to discuss network visibility and techniques to extend that visibility fabric to achieve pervasive network traffic collection. We're going to talk about how to build solutions to capture and deliver network traffic from anywhere to any tool or team that needs it, and show you the analytics visibility and machine learning capabilities available in the latest DMF analytics release. Our session today will present a deep dive of some of that DMF functionality. So let's start by taking a 35,000-foot view. The DAN's monitoring fabric, or DMF, it enables organizations to have pervasive visibility of the network. And let's talk about what that means. DMF is a next-generation network packet broker plus tools that uses DMF controllers as a single pane of glass. And by this we mean the controllers, they auto-recognize and auto-program an Ethernet switch monitoring fabric and smart nodes. You don't need to log on to any of the switches or smart nodes. The controllers make it simple to configure and administer a scale-out monitoring fabric. The monitoring fabric is built on a leaf-spine architecture that everyone is mostly very much familiar with these days. And the great thing about it is that it can scale out as your monitoring needs grow. This includes the switch fabric itself, which can consist of switches at other sites. And we'll be taking a look at this topic today, all managed by the DMF controllers. And it includes the smart nodes. You can scale out based on your throughput and performance requirements. One of our goals with DMF is to help our customers deploy a centralized tool farm that provides pervasive visibility of north-south, east-west, and even VM-to-VM traffic. And so DMF helps to eliminate silos of network packet brokers, just connected to certain parts of the network. It eliminates box-by-box configurations with the controllers. Therefore, it eliminates silos of tools that are connected to only part of the network. Right? So now you can achieve that centralized tool farm, helping to reduce costs as well as gain better visibility. So organizations can use DMF to provide this network monitoring to multiple groups of users. And so now you have one network packet broker solution, which helps reduce costs of multiple NPB systems throughout the network. Another goal with DMF is to help reduce mean time to resolution. We refer to this part of the solution as our network time machine. And this is the ability to use analytics node to see the flows and using integrated workflows with the recorder node via the controller to get the actual packets from a single console. So let's get started. We have a fantastic agenda for today. Mark will show you how to program DMF from a perspective of extending the modern network packet broker using techniques such as tunneling to obtain pervasive visibility. Mark's going to describe the different kinds of tunnels and show us how to configure them. Now, then David's going to come on and he's going to share some of the key use cases and scenarios using these techniques, enabling data collection across mixed environments and best practices for operations. So David's going to show us how to use the configurations that Mark is going to show us into real-world use cases, sharing policy configurations. And then we'll have Kevin come on and discuss and demonstrate the visibility and machine learning capabilities of the analytics node component of DMF. When we're done, I'll wrap it up, and our engineers will stay on the line to answer any questions that you may have. Mark, over to you.
Thanks, Tom. I'm going to go ahead and dive right into it, DMF tunneling. I'm going to go through some of the capabilities, some options that we have there, and at the end I'll do a quick little demo of the configuration options inside of the DMF controller. So one of the things we have to think about is what is DMF and tunnels? What do they have to do with each other? Why are we using tunnels? What are we trying to solve from that standpoint? And where we're seeing tunnels used is when you've got multiple locations It could be remote sites. It could be multiple data centers. It could even be different places in your campus. And the customers are wanting to see and have visibility into those networks. And at the same time, they have centralized tools. They have tools that are maybe in a primary data center or maybe in the primary and a secondary data center, but they've got that centralization of tools because, well, let's face it, tools are expensive. So, at that point, how do we do that? How do we get that traffic from those different locations, from those different areas of the network, and get those back and into the DMF fabric? The other piece that we're seeing is customers are looking at, how do I enhance my troubleshooting? You can probably envision that guy running down the hall with a laptop and a console cable or an Ethernet cable so they can plug into a switch and configure a monitor session or a span port and then do some Wireshark captures and have that Wireshark capture on their laptop. That's okay for if if it's all local, but what about those remote sites? What about those sites that you can't get to very quickly? How do you get those packet captures? So the other piece is virtual environments. There are a lot of virtual environments out there. They're actually very common within, a number of customers, a large portion of customers. How do I get visibility into those virtual environments? How do I see the traffic going between VMs? If it's on the same hypervisor, it's not even hitting the network switch. So how do I see those types of things? And this is where we're seeing tunnels help solve those issues, solve those problems. The first example that I kind of talked about is, I have remote DCs that I want access to, or just remote sites. These could be remote sites. In this diagram, I have HA pair of DMF controllers. They control the DMF switches that are located at each of these sites. And maybe in this circumstance, I only have tools at this data center 1, at the primary data center. How do I get the packets back from these remote sites and into my tools so that I can analyze the information, analyze those packets? In this circumstance, we're going to build GRE core interface tunnels between these switches. Having those GRE tunnels between the switches and having them as core interfaces allows me to, when I'm creating that DMF policy, that I can actually identify those interfaces as filter interfaces, as source interfaces in, say, remote DC1. And when I go to my delivery interfaces, my destination for the packets that go through this policy, that make it through this policy, I can identify those delivery interfaces. They can all be managed in that one location through the same set of DMF controllers, which makes it a lot easier to build those policies and to be able to actually manipulate and filter that traffic to find what I'm looking for. So again, those are GRE tunnels used as core tunnels, core tunnel interfaces. As you see on this slide, that's just another representation here of what that can look like if you have that DMF switch at the remote location. But what if I don't have that DMF switch at the remote location? How do I get traffic from those areas? In this circumstance, or in this situation, I'm going to create a receive-only tunnel interface or tunnel endpoint in my DMF switch. That's going to be a physical interface that connects into the production network. I'm going to put an IP address on that tunnel interface so that when I go to the remote location, I set up my monitor sessions or span, and the destination for that is actually going to be a GRE tunnel. That GRE tunnel will have a destination IP address of the DMF switch back at the primary data center. Packets that are captured will be encapsulated in GRE and transported via IP back to the primary data center across the production network and into that tunnel interface. which then puts it into the DMF fabric, which I can then use policies to filter and send to the appropriate delivery interfaces. Similar to that, we're seeing customers expand that into the campus. They want that visibility into the campus. These can be IDFs in your campus network where I will do the same concept that I just talked about at the remote site without a DMF switch. I'll set up a monitor session with the destination of a GRE span tunnel, and that tunnel has an endpoint IP address of the DMF fabric. This allows me to view and have visibility into traffic all the way down to the access layer, as close as we can get to those clients, to the hosts that are out on the network. So again, just another example and another option you have is GRE span to do GRE span tunnels into this DMF fabric. Another option is through vCenter integration. And what we have here, like I talked about earlier, is I have that VMware virtual or just virtual environment. I need to be able to see between the traffic between VMs. Getting to that is very easy. You have to be able to get into the virtual environment in order to accomplish that. We do that with two different methods. We can do the encapsulated remote mirroring, ERM, and again, that is a GRE tunnel that you're setting up between vCenter and the DMF fabric. That tunnel is built across the production network. If I am capturing packets in this case, I'm going to again encapsulate those into a GRE. Those are going to be IP packets that will travel across your existing production network and into a physical interface into the DMF fabric. That physical interface again is just has an IP address associated to it and is the endpoint of a tunnel endpoint or target endpoint. The other option is to use an actual span. In this circumstance, what you're going to do is you're going to take a NIC that is on an ESXi host. That NIC is going to have a physical connection into the DMF switch. It is going to appear in the DMF switch similar or just like a filter interface. And you're going to be taking traffic from or within vCenter in your VM virtual environment. You're going to be sending across that and capturing and spanning that across into the DMF fabric. The advantage to doing the span like this is that you're setting this up completely outside of your production network. That traffic that's being sent, those packets that are being captured, are not impacting anything bandwidth-wise, utilization-wise, processor-wise in your production network. Just another option or capability or feature that is available to you if you're using that vCenter integration. I can tell you this is really cool. I've seen this live. I've seen where they have set it up using an ERM. DMF controllers are talking to vCenter via API. DMF controllers are aware of what's going on in vCenter, whether they're adding or removing VMs. Those will automatically show up in the DMF controller because of that communication between these two. Within the DMF controller, when I go in and I'm setting up policies, I can actually select VMs as my filter, as my source. And I can then filter that. I can grab whatever information I want, whether ARP packets, ICMP, HTTPS, whatever it is. I can grab that and then send it to my delivery interfaces or tools, whether that's the recorder node or whatever other tools that I have sitting out there, or I can send it through the service node to do, say, deduplication or packet slicing. It is really cool to see. The customer I saw this with, they actually just had Wireshark hanging off as a tool, a server with Wireshark on it, and we could actually see the impact of making changes to that policy and seeing the traffic between two VMs on the same ESXi host. It was awesome. So if you have a VMware environment and you have DMF, you definitely need to leverage this option. It is really fantastic. All right, that concludes the slide portion of this. Let's jump into a demo. Go ahead and jump out of this. I'm going to jump into a DMF controller. And from this controller, what I'm going to do is demonstrate some of the different configuration options that are available to you when building tunnels in the DMF controller. All right, so let me show you some of the options. I'm going to go ahead and click on Fabric and then Switches. I'm going to select the switch that I want to build the tunnel on. I am going to click the hamburger to the left of that switch name. I'm going to create tunnel interface. Need to zoom out just a little bit so you guys can see the whole configuration box here. In that box, you'll notice that there are red asterisks. Those red asterisks are telling you what is required. So you will have to fill in any of the boxes that have those red asterisks. You will give the tunnel a name. You have the option to rate limit that tunnel. Very useful if you've got limited bandwidth on WAN links or links between the DMF fabric switches when you're working with remote tunneling. And that gives you different options. You can do whether it's kilobits, megabits, or gigabits. And then in addition to that, you've got your receive and transmit. This is set up as a bidirectional. If I want to make this a receive only, for example, if I'm going to be bringing in Greenspan tunnels into this, so I'm not going from DMF fabric to DMF fabric, I can set this up as a receive only. Notice when you make that change, the red star next to the loopback interface is no longer required, versus if I'm in a bidirectional, it's there, or in a transmit only, it's also there as well. This is also where you configure like the source IP address for that tunnel, the gateway, so it knows how to get out. And you can also set up a remote IP, so you can give it a specific destination for this tunnel. Or, like I said, if you were doing, for example, a Greenspan tunnel into this tunnel, and you've got it set up as you want to have multiple tunnels that can terminate on this interface. It gives you some nanograms here. It tells you, hey, if you're using the wildcard, it has to be receive only. So there's some helpful hints that it's giving you when you're doing these types of configurations. So go ahead and take that out of remote. You're going to set up your parent interface, and David's going to talk through some of this and show this to you as well, and get into the details of this setup. But I just wanted to show you some options that you had when you do get into are configuring that tunnel. And again, this is if you're setting up DMF fabric to DMF fabric tunnel, or a core tunnel, or this is also where you would go if you were going to set up a tunnel for Greenspan termination as well. I'm going to jump over to monitoring and tunnel endpoints. This is where you're going to set up your vCenter integration. So if you want to set up that one of the ERM tunnels between your vCenter and the DMF fabric, you'll use the tunnel endpoint to do that. And there are some, just a quick look at what that configuration looks like. It's very simple. You're just picking the switch, you're picking the interface, and giving it an IP address. Again, that's just on that tunnel endpoint. That's creating that connection between the DMF switch and your production network, for which all of that tunnel traffic would flow through from vCenter. Cancel that. And again, just a quick look at if I jump into integration and vCenter itself, you're going to see that I have the ability to go in and actually choose the vCenter that I'm connecting to. You've got multiple options whether you're going to do a span or if you're going to set it up as maybe an encapsulated, remote tunnel from that standpoint. So again, this is where you would go in and make those configurations. You would set up the cluster endpoints, and then if you wanted to, you could target specific VMs out of this as well. So again, just wanted to show you a quick look at where you would do some of that tunnel configuration in the DMF controller. Like I said, David's going to go through some specific configurations and show it to you in action. Okay, I think that's it for me. Go ahead and hand it over to David.
Thanks, Mark. Now that we understand how to establish a GRE tunnel, how can we take advantage of it to monitor traffic? Let's review a few situations where we can use it on the filter side. One way to take advantage of a GRE tunnel being used as a filter interface would be by encapsulating span sessions directly on the monitored switches and tunneling it via GRE to our DMF filter switch within the DMF fabric. In the Arista world, being able to create a span session on a switch and encapsulating it via GRE is called Greenspan. This can come in handy when you want to monitor remote sites, such as branches or a small remote data center, where it wouldn't make sense to have a dedicated DMF filter switch. Getting a bit more creative, we can also send drop packets from select monitored switches via GRE into the fabric for analysis. This can be beneficial in testing the security of a network, or troubleshooting to gain greater visibility into why the packets are being dropped. You can also take GRE tunnels generated from other visibility tools, even from another DMF instance itself, and send it to the tools connected to the local DMF instance. Moving on, we can use a GRE tunnel as a core link. As Mark discussed earlier, we can use a GRE tunnel in this situation to connect the switches within the DMF fabric together, so long as they're managed by the same controller. In this situation, we have 3 remote data centers and 2 tool farms. By using multiple policies, we can take traffic from any one of these data centers and send it via GRE to any of the tool farms, even if these tool farms are geographically disparate. When the GRE tunnel is first formed between the 2 switches, one thing we need to ensure is that we've configured the GRE tunnel as a bidirectional tunnel. This is so LLDP can be used to auto-discover the link within the fabric, so DMF will recognize that this is a core link. Be aware that if the tunnel goes down for any reason, DMF treats the link failure as if it was a physical link failure. Yet another way we can use a GRE tunnel is when we want to use it to deliver traffic to a tool located remotely. Rather than send the bulk of the traffic to the site unfiltered, we can first filter and service it at the source, reducing the amount of throughput needed to the remote site. It also comes in handy when you're in a pinch and you need to send the traffic for analysis to a tool at another site at the last minute, maybe to a colleague for them to review. All the ways you can use a GRE tunnel, kind of what methods do we have at our disposal to monitor it? Within the DMF controller itself, we can monitor the utilization via the interface policy statistics available to us and visualize rates such as transmit bit rate, receive bit rate, and bidirectional bit rate. And if you have an analytics node, we can even monitor statistics over time, such as tunnel utilization, tunnel throughput by direction, bit rate over time, and more. Kevin will kind of dig into a little bit more of that in the coming section. That wraps up the presentation portion. Now let's move on to some of these tunnels in a demonstration. In this demonstration, I will demonstrate a few of the tunnel types we previously reviewed. On your screen, we have a fairly basic DMF topology. We have 3 filter switches, a remote filter switch, a core switch, and a delivery switch. What we'll be focusing on specifically is the remote filter switch as well as the delivery switch. What I'll show is the configuration of the GRE tunnel for the core link, as well as the configuration of a GRE tunnel to a remote tool. In this case, a Wireshark client on my local laptop, which is connected over an IPsec tunnel. We'll then configure a policy to get the traffic generated from the Ostinago traffic generator on Ethernet 40 of the remote filter switch to my Wireshark client. Let's get started. All right, so I just logged into my DMF controller instance here. And from the controller, what we're going to do before we start configuring anything is do a topology review. So I'm going to go up to Fabric here and just click on Fabric. Just click right on the tab there. And what we'll see is that we've got filter 1, filter 2, filter 3, our core, and our delivery switches, as well as the service node, which isn't part of this demonstration, configured here, but we don't have the remote filter actually part of this configuration here. So what we're going to do is we're going to set up our core link between our remote filter switch as well as the delivery switch. So let's get started here. So to do that, we'll work from the filter switch first, the remote filter. So we'll go right to Fabric here, Interfaces, and we have to configure a MAC loopback for the GRE tunnel to source from. So with that, let's find it. Let's do a filter here. So we'll go to Filter, Filter, and we're going to go to Switch is, and the value would be, let's do, I think it's Remote Filter 1, I believe is the name. Nope, it's probably Filter Remote 1. There we go. And with that, we can kind of see that we've got, the Ostinago traffic generator on Ethernet 40, which is generating traffic currently, but it's not going anywhere because it's not connected to the fabric and there's no policy set up for it. Moving down to Ethernet 46, we can see that's up as well, but that interface is really an unconfigured interface at this point because we have not set up anything. So we're going to go to Ethernet 45 first. We're going to configure that MAC loopback for the GRE tunnel to source from. Just hit yes here on the MAC loopback. Hit save. And so now that is saved. We're going to go into our GRE configurations. We're going to create that tunnel here. And so the DMF switch is going to be filter remote 1. The interface is going to be Ethernet 46. That's what's connected to our fabric to get this to the DMF fabric. The loopback interface, there should only be one option, Ethernet 45 here. The decap key kind of keeps the GRE tunnel unique. This can be anything above 4,097 up to a little bit over 4 million there, or 4 billion, excuse me. We're going to use the decap key 8080. So we're going to add here. We're going to give the tunnel a name. So we're going to say this is the tunnel to delivery. Well, let's just do this, ton to delivery. And it's nice to put the word tunnel in there. It says that it must begin with tunnel, but that's more of a recommendation because this will actually go into your interface list. And if you just type in a name here, you can get confused very, very easily as to what this actually is. And so we're going to actually use ton to signify that it is a tunnel of some kind. In order for the DMF controller to kind of connect this as a core link, once again, we do have to have this to be a bidirectional link here. So those LLDP packets can be exchanged appropriately to bring up that connection. So we're going to leave this as a bidirectional connection. And then what we're going to do is we're going to give it a source source IP address here. So let's give it a 10.240.133.207. It's going to be a /24. The gateway address is going to be 240.133.207, or excuse me, not 207. It's going to be 133.1. And then we're going to put the other end, the remote IP, and that's going to be 10.240. That's strange. As I'm just blind here, so 10.240.133.208. Perfect. And so we have that. So I'm going to hit submit here. And so we have one half of the tunnel actually set up here. And now what we need to do is we now need to set up the tunnel on the other side. So we'll go to switch name. We're going to say delivery. Spell here. And once again, we've got to go in here and we have to set up our MAC loopback. So let's set up the MAC loopback now. Let's configure the interface Ethernet 45, MAC loopback yes, hit save. You can see that Ethernet 46 is up. We're going to hit the little hamburger here and create the other end of our tunnel. So this is going to be not the filter switch, but this is going to be the delivery switch. We're going to parent interface 46. We're using the same interface on both switches. I'm going to use the same loopback interface on both switches. Let's make sure that this decap key is exactly the same as the other decap key. So it's 8080. We're going to give it a name. This is going to be the tunnel. Let's do this to filter. Once again, we're going to leave this to be a bidirectional tunnel. We're going to go into IPv4 address here. This is going to be the 10.240.133. This is 208 / 24. Gateway address is 10.240.133.1. The remote would be 10.240.133.207. And we hit submit here. All right. So now, if we look, everything looks good here. If we go to Fabric, we should now probably see, crossing my fingers here, that the remote filter switch is now connected to the topology. And as you can see, it was built as we described it. We're going from the remote filter switch, and we created a core link to the delivery switch. So half of this is done already. Now let's work on creating a tunnel from the delivery switch to my notebook here. So what we'll do is we'll go back into Fabric Interfaces, and within the delivery switch, when it loads here, within the delivery switch, we're going to go to Ethernet 44, and we're going to configure Ethernet 44 for that MAC address. So perfect. We got another MAC address. We can use the same parent interface for our GRE tunnels, but we do, for every GRE tunnel that we create, we do have to consume one interface on the front of the switch there. So we did that. Now we have to create our tunnel. So here's another tunnel here. This is going to be on the delivery. The parent interface is going to be Ethernet 46. One second here, guys. Let me pull this up here. And then Ethernet 44 is going to be the loopback interface. We're going to give this a different GRE decap key. We're just going to say 5000. And we're going to name this tunnel 2 and my last name, which is Candler. Since this is going to be a one-way tunnel to a tool, specifically Wireshark, we can actually change this from bidirectional and just click on transmit only. We're only going to deliver that traffic to my Wireshark client. So now let's give it a source IP here. So we're sourcing from 10.240.133.209 /24. Gateway IP address is going to be 10.240.133. And then the remote IP is going to be my VPN IP address for my tunnel here, which is going to be 10.88.248.33. All right, 10.88.248.33. Perfect. And we're going to set that up here. And then if we look, let's take a look here. Tunnel to Candler, we can see link down. This should come up momentarily here. Let's do a bit of refresh real quick here. And we can now see that that tunnel is up. So with that said, we've configured both a core link as well as a tunnel to one of our Wireshark tools. All right, guys. So now that I have my GRE tunnels configured, what I need to do is create a policy from the Ostinago traffic generator on Ethernet 40 on the remote filter 1 switch and bring it to my Wireshark client here on my laptop. Now, we've already configured the filter interface for the traffic generator. However, we did not actually specify that my GRE tunnel was a delivery interface. So what we're going to do is we're going to go back into Fabric Interfaces here. And what we're going to do is we're going to go to Tunnel to Me specifically and configure this. And what we're going to do is we're going to go to the DMF tab here and say that, hey, this is going to be a delivery interface. And what's the name of that? So I'm just going to put, Candler Wireshark. So it is the Candler Wireshark interface. We're going to hit Save here. And then what we're going to do is we're going to continue to create our policy. So let's go to Policy here. Let's go to the plus tab here. And let's give it a name. The name is going to be traffic, or let's actually use the name of the traffic generator. So Ostinago. And that's going to go to Candler Wireshark. And so action forward it. Perfect. So the rules, I want to transmit everything. I don't want to filter any particular ether types out or any IPs. So we're just going to do any. We're going to go to feeds here, and the feed is going to be the Ostinago traffic generator on Ethernet 40, a filter remote 1. So that particular switch. We're going to go to tools, and my Wireshark client here. So yep, Candler Wireshark. It is the interface, my GRE tunnel. Let's click that. So now that we have that all set up, services, we're not running this traffic through any kind of services at all in the service node. We could associate it with the recorder node. Any traffic going through this particular policy will get recorded in the recorder node. Sure, let's do that. And then there's the summary. We hit save, and let's install the policy on our switches. And as we can see, we now have the policy installed on our switches. So any traffic being generated from the Ostinago traffic generator will be directed to the GRE tunnel on the delivery switch over that core link. So 2 GRE tunnels here. And this is really just to kind of show you, what kind of things we can do with DMF. So let's go take a look at Wireshark. Let's see what kind of output we get. All right, so I have my Wireshark client open up here, collecting traffic from Ethernet interface 4, which is the interface used for my IPsec tunnel here. So we're collecting data, but I want to see the GRE specific traffic here. So what I'm going to do is I'm actually going to put the filter out based on the source address of the GRE tunnel. So let's do that. So let's do IP, and that's going to be 10.240.133.209. So let's put that in there and filter. And here is all the all the traffic that was sent over from the traffic generator. And as you can see, we've got some GET requests here, some HTTP requests, some GET image requests, and we can see that it was encapsulated via the DMF delivery switch here. So we have that, and that kind of wraps up the demonstration here. So thank you guys for sticking with me, and now on over to Kevin to go over the analytics node.
Thank you, David. In this section, we're going to switch gears a little bit and talk about observability, asking questions about the network. We're going to leverage the DMF analytics cluster to do that. I've taken a modified version of the drawing that was presented earlier, showing some remote locations with DMF fabric switches being extended across and capturing traffic into a centralized fabric in the data center. Our tools in this case will be a centralized virtualized tool farm with performance monitoring, application monitoring, etc. The analytics cluster itself is collecting DMF traffic and performance metadata from the network. The first thing we'll do is we'll look at discovering the data that's in the cluster. There's a function called discovery, which allows us to visualize the fields and the records that are being collected. Interrogating some of these, we can create complex queries to look for just tunnels, interface, peak stats, dropped packets, performance overall of the tunnel over time. And we can create dashboards from this information. Dashboards are comprised of applets, visuals, log information, whatever it is that's in the database and records that we want to depict, we can actually put into dashboards. We can customize those to our daily needs. In this particular depiction here, we're showing just our tunnels, remote sites, tunnels to tools, and anything that you hover in the dashboards is clickable and can be used to create complex filters. Finally, we'll talk about machine learning. We'll create models to look at the packet rates, the peak packet rates, and we can actually forecast over time what the growth of traffic might be across our tunnels from remote sites or even to tools. With that, we'll go on to the demo. Okay, I've already logged into my DANS Monitoring Fabric interface. We're going to navigate over to the Analytics cluster. So I'll click on Monitoring, Analytics, and notice here that we're sending a lot of statistics and metadata to the Analytics node itself. I'm going to go ahead and click on the hyperlink to log into the interface. The data that we're sending is going to be stored in indexes, which are records of user data, interface statistics, traffic statistics, and the like that we can use to create dashboards, do monitoring, and also run queries and searches and actually ask questions about what's happening on our network. So my default interface comes up, and under DMF network, this is something David already talked about, interface statistics. You notice you get a general overview of all of the interfaces in the fabric, their roles, what's running, their traffic rates, and all of that. And you can search any of these fields. But for today, we actually want to focus specifically on our tunnel interfaces. So tunnels are going to be traffic coming from remote sites. Maybe it's a distributed fabric so that we've extended out switches into campus environments. Maybe we have something coming in or out of the cloud. And we may have tools that are on a virtual instance as well. There are a few things we want to look at before we create our custom dashboards and our custom searches. On the left-hand side will be a navigation menu that we can open. The ones we're going to focus on today are Discover, which allows us to look at our indices and the documents that are within them, and the Visualize library, which helps us create components such as graphics and charts, and maybe even some running logs. And we'll save those out based on criteria that we choose so that we can use them finally in our dashboards. And then the last piece we'll talk about is the machine learning component, where we take all the data we're collecting, build models and create baselines, and then look for anomalies or changes against the population. So let's go to Discover, and it'll bring up a default view. On the left-hand side will be a list of all the indices that I pull down. So think of these as all of our databases, and inside of those is records and documents and fields that we can look at. For today's purposes, we want to look at statistics. So I'll click on Big Tab Statistics. It'll open up a view, and now we're going to adjust our timeline first. So up in the upper right, it always defaults to 15 minutes. We're going to go ahead and just give ourselves a lot of data to work with. So I'm just going to say 15 days ago, and I'm going to update that. And everything now in this database list will actually reflect the change for that time bound. On the left-hand side then are going to be all of our available fields. We're mostly interested in interface names so we can identify our tunnels, and probably things like packet rates, packet drops, average bit rates, things like that. So one example is the interface name itself, which when Mark did his configuration, he was naming things like tunnels and where they were coming from in parts of the network. So those labels are really good for helping us index and search for things here. So if I click on interface name, a dropdown will show up and show me all of the values. So we know these fields are getting populated and have live data. So if I click a plus, it'll go ahead and add that column with a date stamp and the interface name on the right. I can open that up and I can look from a JSON formatted perspective of all the records, transmit and receive, and all of those stats, and all of my keywords are in there. So then we want to add other fields. So we'll add bitrate. I'll click on plus, and we'll get the bitrate. So now we're looking at megabits per second of traffic going in and out of these different interfaces. But if you notice, we're still looking at everything in the DANS monitoring fabric. So what I'd like to do now is actually create a query, and it's just a free form. So I'm going to use Lucene, and I'm going to say, show me all the interfaces that have tunnel in the name or vCenter in the name. So when I click on that, everything down below then now will represent the results of that query. So rather than go through all the rest of the steps that we want to do here, I'll tell you a couple of things. We can save this query so I can use it later on, so I can have a search. And also, if I want to do just the command line query itself, I can save that. It's most important for building dashboards and things that we save these out as a saved search, because then I can reuse them later on. So I'm going to go ahead and open a previous saved search that I have so we can look at all the fields that I put into it. So I'm going to do tunnel statistics by switch and interface, and we'll use this later on in our dashboard as well. When I do a save, the timestamp is saved with it, so my boundaries as well as any of my search queries. So notice here now in my view, I've got the interface names by date and time, the speed of the interfaces, the bit rates, the peak rate during that time period. We're also interested in any sender receive drop packets that might be coming through those tunnels. And this will help us later when we look at trending and analysis and using our machine learning to do some forecasting. So let's go next to the visualization library. In here, we'll actually create some custom visualizations for our dashboard. So think of these as pie charts, timeline graphs, things like that. I can create a visualization, and I'm going to use Lens, and there's different things you can do here, but Lens is the easiest. It builds me sort of a blank canvas that I can work with. And in this canvas, based on the time frame of notice and my query that I have, I can say, what field do I want to look for? So one thing that's useful on a dashboard is to kind of build an index of the interfaces that I want to use. And then I can select those to look at specific tunnels. So the reason I bring this up is in your case, you might have 15 remote sites or 20 campus sites or something like that, or 15 tools in VMware. We want to have an easy way of being able to select those when we're doing our searches or our queries. So instead of a vertical stacked bar chart, why don't I go ahead and create this instead as a donut or a pie chart? And if you notice, based on just the interface name, I've created a visualization that I can look at any of my interfaces or any of my tunnels. And by simply clicking on this chart now, it'll actually bring me results of just that specific tunnel or that site. So we're going to go ahead and save this out as an element that we can use in our dashboard. And if I want to add it to an existing dashboard, I can say add to dashboards. There will be here. I can create a new dashboard just from this one element that I've already done, or I can add that to my library. So typically that's what we would do. What I'm going to do next is show you one of the visualization libraries that I've already created. And we'll go ahead and confirm that we're moving on. And I'll say open, and I'll search for tunnels. And one of those that we've done is tunnel bandwidth over time, and also showing our peak value. We actually have a line graph showing me all of my tunnels, or all of my sites or my locations. All of this is interactive and clickable. I've done this over 15 days, and you'll notice there'll be values here for the amount of bandwidth, the peak rates, and anytime I click or hover on one of these, it returns those values to me. So this is another element that I can use that I put in my visualization library. So the next step is, let's go ahead and create our dashboard. So click here, down the menu, we're going to go dashboard, and we'll get a list of created dashboards. Many of these are default built into the system already. You'll see DMF interface stats as an example, one of our default dashboards. I have some that I've already created here. So if I click on tunnel, you'll see I have a couple of different views. But let's go ahead and look at the elements of creating a dashboard first. We can also just create a raw visualization. So once again, we talked about doing visualization library additions. I can actually do it from here as well. So what if I just said, I want to go ahead and build my bar chart, and I want to look at an index based on interface name. So I'll click on that, add that to my chart. I'll actually create a query now against that too. So I'm going to go ahead and turn on Lucene query syntax. And you see I've got some preset queries on here. I'll click on those. And now we have an element that we want to use in our dashboard. So I go ahead and save and return. And there it is. So now I can resize this or move this around however I want. I can change colors. There's lots of things I can do based on the lens functions. I also want to go ahead and add a title to this. I'm going to call it tunnel selection and save that. Now next to it and below this, I want to add some of the elements that I've already created in my library. So add from library, tunnel. We'll look at a remote site tunnel performance, which is just one specific site. I want to look at, have a view of all of my tunnels by switching interface. And I also want to look at the one that I've done, my time chart of tunnel bandwidth over time. So if I save this, I can save it as a new dashboard. I can also store the time with the dashboard. So notice I have the last 15 days. So I always want it to come up showing me that sort of time window. I can do that as well. And I can also write in tags here. So if I want to write in, so create a tag and just call it, this is going to be my tunnel tag. And I can call it, let's just say KP selection. Oops, I didn't type. And we'll save that. So now we have a dashboard. We can always come back in and edit this. We can add more elements to our dashboard. We can do other filters, and then we can resave them or save them as new dashboards. I have a tunnel to filter. This is actually my remote DMF switch at one of my campus locations coming in to the DMF fabric in the data center. So when I select that, we are now looking at just the traffic from that particular site and location. And so then over time, I can look at the average bandwidth of my peaks. Down below, I have all of my values. So if you're looking at troubleshooting something and maybe it's a WAN connection or a routing issue or something, we want to look for values of each of these events based on the time frame you selected. And of course, down below, I actually have all of my log views as well that show me some of the names. So if there's error rates like transmit errors or drops, they'll show up in here as well, and you can look for those. The next thing we're going to talk about is how do I apply machine learning to this data so that I can look at maybe anomalies or things that happen outside of my baseline, forecast the traffic on these tunnels so I can look at what's it going to look like 2 weeks, 1 month, 1 year from now for capacity planning reasons. And then how do I then take those results and add those to my dashboard? So let's go take a look at machine learning. So notice here that we're showing a couple of things. There's some anomaly detection jobs that are running, and there's some analytics jobs. So up above, you'll see anomaly detection, and we'll show that pick list next. And there's also things that you can do with data frame analytics. We're going to focus today really on anomaly detection, and we'll talk about some of the visualizations and the analytics pieces in a future NetBuilders. So under anomaly detection, if I were to create a new job, and I already have some running, I think about this as run me a baseline to show me average bandwidth per second, or analyze tunnel performance, maybe drops or transmits, errors and things like that. So I can create a job to do those things. So the pattern that I want to look at is going to be under Big Tab Statistics. Remember, we have to pick our index. I'm going to look for single metric. There's all the data that's running. Say next. The fields I want to look at, in this case, we want to look at bits per second, right? Because I want to create my baseline. So I'm going to go, what is the mean average bits per second? If I want to add other metrics, such as peak packet rates and things like that, I can add those and create a multi-metric job, it's called. But I'm going to say next. I'm going to give it a job ID. I'll just say 20. I don't have to look at any additional advanced settings. I'll say next. It'll check all of my model memory and limits. And if I click here, now it'll start all of my plots. So if I say start immediately and create this job, it'll run through and it'll create my baseline and show me current anomalies over the window that we already have. So let's go ahead and view results. And down below, you'll see if there's anything in red in this time view, we can actually drag our selection over it. It'll zoom in for that particular piece. So we can look at the anomaly score, and so we can click at any one of these. I can also move my slider along on this view just to pick a different section, or actually even stretch it so I can look at a longer time period. Let's go back to one of the ones I've previously created, and we'll drill into some of our tunnel interfaces. So if I'm looking at just our remote site tunnel again, our peak bit per second rate is a job that I've created. So on that link, you'll notice over on the left, I can get a time view of that metric just for this remote site that we were looking at. And I'm going to click on the forecast button in the upper right. So this is my data value. This is my set in the model right now. And let's just say, what does it look like 2 weeks from now? Give me extrapolation of that data over that period of time and predict what my peak rates are going to look like in 2 weeks. So I'll say close. Now in yellow has been our prediction. And so over time, we do see that tunnel bandwidth is slightly increasing. And so if I want to look out, what does it look like in 2 weeks? I can simply click on that and here's the values. And let me slide my window down. And we'll notice if we're exceeding our tunnel bandwidth or our WAN connection bandwidth 2 weeks from now, we know that we have to actually do something to increase that bandwidth. It also might be from a tool perspective. Maybe I'm sending this to some tool that's in your VMware, and the traffic that I'm analyzing has been increasing over time. I may need to consider that I have to add another interface to that tool, or maybe add another tool and cluster it in the DMF fabric. So how do I use this on a daily basis? Let's go back to our dashboard. We're going to go back into edit mode. Right? And we're now going to go add a machine learning interface job so I can actually watch this traffic based on whatever queries. And so we're looking at an anomaly chart. We're going to click on our peak packet rates right here, which is 15. And we're going to say apply. That's my job number. And we'll confirm that configuration. And now, down below, we're going to get a chart based on my 15-week criteria and my values up above. I can click now and select what do I want to see. Are there any scores that are critical or any other warnings in my anomaly chart? So that's now part of my dashboard. So anytime I look at particular sites and remote sites, if I have something that maybe exceeded the bandwidth or spiked far above the average, that is now part of my dashboard. I can go ahead and save that out. And I'm going to switch back to view mode. So that ends our demonstration for today, talking about DMF analytics. We talked about dashboards, creating your own dashboards, your own elements. How do we do specific monitoring for our tunnels and our remote sites? So Tom, back to you. Thank you.
Thanks, Kevin. That was great. Well, that's a wrap for our session for today. But before you go, I wanted to share an update with you and remind you about our DMF labs. They've been updated significantly, and you'll find an updated user interface and new labs like the network time machine, and there will be more to come even. So just go to labs.arista.com, sign up with your work email address, and then you'll have access to this virtual sandbox where you can follow the directions or do your own thing. And remember, it's free. So definitely recommend to take a look at that. And with that, I'd like to thank, Mark, David, Kevin for your presentations today, and for everyone who joined us on the call here today. Thanks for taking the time to be with us. Your time is, very important to us. We appreciate it. We hope we provided some insights on DMF for you today. So we'll stick around and answer any questions that you may have. Thanks.